Today we are going to learn about current electricity. Current electricity, see here, we're going to read the text first and understand the concept. Again, read the text. So current electricity is made up of moving electrons or ions. You know what moving electrons and ion means? Like, you see, electron is like negatively charged, and it is in the like orbit of an atom. Atom is here. This is atom. This is positively charged. There are protons here, and then neutrons, which are like no charge, nothing here. Okay, and then they're like, because of moving, when they move and they're like loosely packed, those, yeah, it gets its name current because people once thought electricity that electricity flowed like water. You know how water falls, right? Like water flows like this. You know how water flows, right? Yeah, it flows like this. Yeah, yeah, that's what. Because water flow, because like people thought electricity like flowed like water. That's why they named it current. You know, like how current works. Yeah, like that. And actual current flows because of free electrons. Because of free electrons. You know, like free electrons. You know how when there's an atom here. See, there's an atom here. Fuck. There's an atom here. Okay, and then there's a free electron here. Minus charge. This is also minus charge. There's a free electron here, and then yeah, these are electrons. This is a neutron. I mean, nucleus of the cell. This is like free electron. Because of free electrons, conductors. In conductors, there is at least one electron which is loosely bound to the atom. In an I know I'm telling in an like this is the orbit, this is the nucleus, and then this is this thing, neutron, electron, which is like loosely bound. It's like mostly here. It is like loosely bound. It doesn't have electronegativity, and then yeah, it is loosely bound. Uh, to like loosely bound to the atom. It is the free electron that knocks the next free electron of other atom and transfers electricity. You know what they say? Imagine this is this thing, nucleus of the cell, and then this is the orbit, and then there is one loosely packed one. There's not loosely packed one, and then this is also is one thing. There's the orbit, and then there's the loosely packed one, and then there's not the loosely packed one, and then okay, and then this just goes, okay, and then this just like what happens when the loosely packed just gets rubbed or something, it goes boom, boom, and then this thing, okay, this will come here and it will take this place, and then this will go somewhere else, and it will go here or something, and then it will go boom, and then this will go somewhere, and then probably here or something it will go boom, boom. Yeah, all that chain reaction transfer electricity. So yeah, electricity transfer means that basically that, like electrons moving from one to other. Electric currents are driven by an electromotive force or EML. Electric currents, right? Electric currents, they are driven by electromotive force. You can say that EML. They are, yeah, EML. It is mostly driven by battery. Batteries, right? You know how batteries are. They're driven by batteries. In which case of force arises because chemically more favorable for electrons to be in one terminal of battery than other. It is more favorable for the electron to be in one terminal of the battery than other. There's a battery here and there is a battery here. It is more terminally to better be here than here, so it comes here. There's a potential difference between two terminals. A potential difference is set up when there is difference in charge between 2 points. So you see here there will be like what they are saying, uh, when there's a potential difference between two terminals. There's a battery here, then there's a battery here. Okay, and this one is fat, this one is not fat. Then there's a potential terminal difference. Okay, so electrons will literally move here because there is a potential difference set up when there is in change difference between 2 points. They'll go here then rather than here because it has more like favorable, more chemically favorable for the electron. Where you want to go, you want to go to a mall or something because it's like good, rather than going to some, I don't know. I rather go to library than mall, but you guys are not nerdy, so just gonna say you go to mall or something. Yeah, you guys are not, yeah, so yeah. But this is current called direct current, DC. Oh, DC. You know what DC means? Yeah, DC, direct current, because you know when you're a direct guy, like direct guy, you call DC. Yeah, you might not know the joke, but yeah, it goes only in one direction. It doesn't go in alternating direction. It goes only one direction. One direction. That's it. One direction. No alternates. Yeah. One direction. An alternating current. Oh my god, alternating current. You know what that means? Alternating current. Alternating current. You know who invented alternating currents? Tesla, bitch. Tesla. It changes its direction of flow at regular intervals of 50 seconds, 50 times a second. Like this will be this thing flow, okay, in DC, and this will be the flow, okay. It will be like that forever. I mean, not forever, but yeah, it will be like this, okay. But in alternating currents, this will be the flow, okay. Every 50 times, a regular 50 times a second, okay. This is the interval 50 times a second, and then it will change like this, and then it will become like this. So yeah, this page is explained, I guess, and this much is explained. Let's move on to next thing. To flow, a current must move around a circuit, a loop of electrical conductors. To flow, a current must move around a current loop of electric conductors. You know what that means? To flow, a current must move around a circuit. Circuit, right? A loop of electrical conductors. If a current flows through a several resistors, example light bulb, you know what resistor means, right? Is wired in series and resistor shares a power, but if resistance has separate connections with the battery, then the wiring is said to be in parallel. but 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 if the resistance has separate connection, okay, if the resistance, there's a resistance, right, has separate connections with the battery. This is a battery. It has the resistors of resistors has separate connection. Okay, the wiring is said to be in parallel. It is said to be parallel if it has different. Okay, this is the resistor, and then it has different this thing. So it is called parallel. In summary, all circuits need a force to make the current flow. All the circuits, they need a force. You know what force is? That is EML. They need that force to make current flow. I'm gonna teach only like three this thing. The force, the electromotive force, or EMF. You know what that means? EMF, electromotive force. Remember this thing, okay? EMF, 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 electromotive force. Electromotive force has to overcome electro resistance to make current flow. Resistance, right? There is a resistance here. It has to like overcome it. Yeah. This breaks. And then electromagnetic force, motive force goes through. Circuits with batteries work with direct currents. Circuits with batteries, okay, they go in direct, okay, they go like direct, boring ones. Blech. Mechanical generators usually produce alternating current. You know what mechanical generators are? No, mechanical generators, like, I don't know, wind turbine. Wait. Oh shit. Wind turbines, fuck, it looks like a sunflower. Yeah, it goes like this. Mechanical generation usually produce alternating currents because, like, you need a alternating current so that the energy goes there to start it and then come back like this. It should be like this also, and this should be like this also. So household electricity use alternating current. Like, there's an electric bulb here, okay? Freaking bro, electric bulb here, okay? And then it needs alternating current. And yeah, have you seen solar panels? If you don't turn it off, it will go like this to start it. Again, you need alternating currents, household things, solar panels. Yeah. What does voltage mean? Wait. Let's summarize this. Shit. Electricity. Shit, let me check. Okay. Electricity is made up of moving electrons. Like moving electrons, they knock over. It gets its name because it flows like current. I showed you that. Because it flowed like they thought like that. Shit. And then it didn't. It doesn't. Conductors have at least one loose thing. So it gets knocked over and goes just a chain reaction and becomes electricity. Loosely bound, conductors at least have like one electron, one single electron, which is at least one electron in their atoms, which is loosely, okay? because conductors, let energy flow through them, electricity flow through them. Electric currents, correct currents, right? They're driven by, I showed you, EML. Say EML. Say with me, EML. See, EML. This is often driven by battery. Batteries, they drive EML. Because of them only EML happens. If there's no battery, no EML happens. In which case of force arises because chemically more favorable for electron to be in one terminal of the battery than the other. Okay, if there is like potential difference between two terminals, okay, two batteries, okay, and then electricity will flow here because there doesn't have like much difference here. Here it has much difference, okay, between 2 points. This current is called direct current. Like when there is like difference here, no, and then current flows like here and not here. So in this battery, okay, it's called direct current. It goes only in one direction, it doesn't go anywhere. Alternate current, they go everywhere. No, not everywhere, but it changes its direction of flow at regular intervals 50 times a second. Oh, damn, 50 times a second? You know how fast that is? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Shit. This much time in 1 second. One singular second. Alternating currents do that. Okay, they revised this part and then to flow a current must move around a circuit of loop current. To flow a current must move around a circuit, okay. To move, you know how to move. The circuit must loop around the loop. You know how to loop? Loops. The loop, yeah. It should loop around the electrical conductor. There's this. Okay, let's assume this is the copper wire, okay? Like copper shit. Copper blob, okay? Block, okay? And it may just loop around, okay? Hey, like circuits. They should like loop around. If current flows through several resistors, it's like current, okay. This current goes through a resistance, okay. Resistance, you know how resistance are. Bulb is a resistor, and then it goes close, yeah. Then it glows. It's called resistance. Electric bulb is called resistance. You know what resistance is? R is a bulb, okay. The circuit is wired in series. And the resistance share the power. Circuit. You know what circuit means, right? That they loop around the electrical conductors. They are wired in series. And resistance share the power. They also share the power. But if each resistance has a separate connection with the battery, then the wiring is said to be parallel. But if each resistor, okay, it has a separate connection with the battery, and then this goes here, it's said to be parallel. In summary, all currents need force to make this You know what I told you? Circuits. The force they need is EMF. Freaking F. EMF. 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 Okay? To overcome the electrical resistance. Electrical resistance. All the bulbs and shit. To overcome that, you need EMF. EMF. Freaking EMF. Mechanical like generators, what I told you? Like shit. Turbines. This is a turbine. Don't judge me. I'm drawing with my fingers, bro. Okay, this is a turbine and it uses alternating current. Alternating current, they switch 50 times a second. Yeah, that alternating current, generally they mechanical generators they use. Household electricity also it uses. In a house, freaking house. Okay, it uses alternating currents 1 and 2. Because it needs alternating currents. In your house when light goes. That's common in India. Yeah, the light goes, generator happen. Generator shit. Then it goes like this. It is also alternating current. Because you need alternating currents to make, direction happen and then electrical flow happen. So yeah, so I hope you understood everything I just said. I don't know shit, I just taught you that. Yeah, I don't think I'm going to get any likes or views. Bye bye guys.